All right, in regards to multiplicity, we want to pay attention to how the function crosses the x-axis. So if you're just looking right around that x-intercept or that 0, how is the graph behaving? If you're only looking right here, I kind of see a linear function which has degree 1, right? So that is a multiplicity of 1 because it goes straight through the x-axis. It doesn't curve or bend. This right here looks like a cubic function. Well, guess what? That is a multiplicity of 3 because it goes through the x-axis, curves, and keeps going. Here, your function drops down to the x-axis and then turns away, looking very similar to a quadratic. That is a multiplicity of 2. What that means is that if I was to write a polynomial for this graph, using the zeros and their multiplicities, I could make a pretty educated guess on what this function is. Well, if this x-intercept is at x equals -3, that 0 comes from the factor x plus 3, right? We know that. This x-intercept is -1. We know that that comes from the factor x plus 1. And this factor, or x-intercept I should say, is 2, which comes from the factor x minus 2. Now, this is only 3 zeros here. 1, 2, 3. 3 factors, right? Clearly, this function is not degree 3. Based on in behavior we learned yesterday, this has got to be an even function. So where is that coming from? Well, let's see. What we can do is bringing those factors we just talked about, x plus 3, x plus 1, x minus 2, all coming from this polynomial. Well, the multiplicity also tells us how many times that 0 occurred. So looking at the x plus 3 multiplicity on the graph, that came from a multiplicity of 1, this came from a multiplicity of 3, and this came from a multiplicity of 2. Well, that actually correlates to the exponents. This is a first power, this is a third power, and this is a second power. It's because it means that this occurs twice. We know now that that's what this exponent means to this binomial. So if you have this 0, which comes from this factor, occurring twice, you have a multiplicity of 2, which causes the graph to go down at that point on the x-axis and turn away. So now, knowing this, my new polynomial for that graph is x plus 3, x plus 1 to the third power, x minus 2 to the second power. So the relationship is, how does the graph interact with the x-axis? The way these turns happen tell us the multiplicity. Straight through, multiplicity of 1. Curve and continues to pass through, multiplicity of 3. Turns around, multiplicity of 2. Then I take that information and I use it to write this full polynomial function, which has degree 1 plus 3 plus 2 of 6, which matches the even end behavior.